58 million years ago, a 13-meter serpent patrolled the flooded jungles of South America, the largest snake that ever lived. Weighing over a ton, this creature could crush a crocodilian. Titanoboa was the apex predator of an entirely new world, one the dinosaurs had just vacated. Through AI reconstruction, we can enter this lost world, 60 million years before the first humans walked the Earth. The dinosaurs had vanished just 5 million years earlier. The world was broken and empty, waiting to be claimed. Into that silence slithered something extraordinary. How did one species come to rule the planet's most biodiverse ecosystem? Titanoboa did not simply survive the dinosaurs' disappearance. It thrived because of it. 5 million years after the extinction, ecosystems were still rebuilding, fragile, unguarded, wide open. The apex predators were gone, the large herbivores were gone. An entire food chain had collapsed. Snakes, once small, secretive creatures, suddenly had room to grow. And grow they did. Opportunity alone cannot explain a creature of this scale. Something else was at work. Something in the planet itself. 66 million years ago, the impact that ended the dinosaurs also triggered dramatic planetary warming. Global temperatures climbed. The tropics became hotter and wetter than anything alive today has experienced. For cold-blooded animals, heat is fuel. The warmer the world, the larger a reptile can grow. Titanoboa's size was a direct response to one of the hottest periods in Earth's history. Hidden in the fossil record, a world so hot it produced the largest serpent ever to exist. If extreme heat shaped Titanoboa's body, what else did this superheated planet produce? What world did Titanoboa inhabit? The answer lies in a world so alien and extreme that nothing alive today can truly compare. Imagine a world with no seasons, no frost, no cold nights, a planet locked in permanent, suffocating tropical heat. This was the Paleocene Epoch, 60 million years ago, a superheated Earth unlike anything alive today has known. Average global temperatures were 810 degrees hotter than today. The tropics were not merely warm, they were extreme. The polar ice caps were dramatically higher. Entire continents were draped in jungle. For a cold-blooded animal, this was paradise. Heat is not just comfort for a reptile. Heat is power. The hotter the environment, the faster a reptile's metabolism runs. The faster the metabolism, the larger the body can grow. Titanoboa was not an accident. It was a biological equation. More heat, more energy, more mass. Simple, terrifying mathematics. The planet itself built Titanoboa, a living record of the most extreme climate Earth ever produced. But Titanoboa did not rule alone. The Paleocene was teeming. Strange creatures filled every niche the dinosaurs had vacated. Giant lungfish, enormous crocodilians, massive freshwater turtles, creatures with no living equivalent today. Everything in this world was supersized. The heat didn't just grow Titanoboa, it amplified an entire ecosystem. What other creatures shared this world with Titanoboa, the largest serpent ever to exist? The answer is stranger and more terrifying than you might imagine. It begins with a single fossilized bone. That bone changed everything we thought we knew, a window into a world lost for 60 million years. But who found it? And how did a single Colombian coal mine reveal the most important serpent discovery in scientific history? Colombia, 2002. A coal mine near the town of Cerrejón. Workers weren't looking for history. They were digging for coal. Instead, they uncovered something 60 million years old beneath their feet. A single vertebra, unusually large. Nobody on site knew what animal it could belong to. The fossil was sent to scientists. Paleontologist Jonathan Block examined it and was baffled he recognized the shape immediately. A snake vertebra. But the scale seemed impossible. No living snake produces a vertebra this size. This was something entirely new to science. Teams returned to Cerrejón and excavated deeper. What they found exceeded all expectation. More vertebrae, dozens, then ribs, then skull fragments, an entire animal emerging from the rock. Scientists calculated body length from vertebrae dimensions. The number was staggering. 13 meters. 13 meters, over a ton in weight. The largest snake ever to have lived. Confirmed. The fossils revealed more than size. Alongside Titanoboa's bones lay remains of other enormous creatures. Giant freshwater turtles with shells wider than a dining table. Crocodilians stretching beyond 6 meters. Titanoboa's world was not empty. It was crowded with giants, all shaped by extreme heat. Every creature in this ecosystem was enormous, each a product of the same relentless heat. Titanoboa was the apex predator of the ancient swamps, the largest creature in its world. But how did it hunt? How did a snake this massive bring down prey? That question still haunts scientists. 60 million years ago, something moved through the swamp. Silent, patient, unstoppable. Titanoboa did not chase, it waited. That patience was its greatest weapon. Across the swamp, a giant freshwater turtle moved toward the bank. Unaware, the turtle was enormous, formidable by modern standards. But not here. Beneath the surface, Titanoboa accelerated. The water barely rippled. Then, an explosion of motion. The strike was faster than anything its size should allow. Constriction was the method, coils tightening with every breath the prey attempted. Scientists estimate Titanoboa's constriction force exceeded that of any living snake by a significant margin. Over 400 vertebrae, each a joint, each adding force. A machine built for pressure. Titanoboa did not only hunt turtles, evidence points to larger, more dangerous prey. Alongside Titanoboa's bones, crocodilian remains, not prey, competitors, possibly something more. 2 apex predators. Same swamp. The fossil record offers no clear answer to what happened between them. Did they compete? Did they clash? The bones are silent. The question remains open. Titanoboa dominated for nearly 3 million years. Nothing challenged its supremacy. 3 million years, an almost incomprehensible reign. Then it ended. Something changed in the world around Titanoboa, something it could not adapt to, something that erased it entirely. To understand that end, we must first understand the world Titanoboa ruled. 58 million years ago, the world was unrecognizable. No ice caps, no seasons as we know them. Relentless, suffocating heat. Average temperatures hovered near 32 degrees Celsius. The planet was a greenhouse. In that greenhouse, life grew enormous. This was no swamp like any that exists today. A world built on excess, heat, water, life. Titanoboa fit perfectly into this world, not despite its size, because of it. Every feature answered a demand the environment made. Cold-blooded animals grow larger when temperatures rise. The heat was not a challenge for Titanoboa. It was fuel. Titanoboa was not alone. This ecosystem was crowded with giants, every niche filled, every waterway contested. Carbonemes, a turtle the size of a dining table, shared these waters. Armored, ancient, seemingly untouchable. Fossil evidence shows Titanoboa consumed them. That shell, that armor, it was not enough. What made Titanoboa effective was not size or strength alone. Its patience matched to its power, an ambush predator in warm, slow water. Every adaptation locked into place, a perfect ecological fit. How did one predator of this size shape everything around it? A predator this dominant does not simply hunt, it reorganizes. Every creature in the swamp responded to its presence. Where Titanoboa waited, other animals moved differently, avoided, adapted. The entire ecosystem bent around one creature. That influence, invisible, unmeasured, is the real legacy of Titanoboa, not the fossils. The silence it created, this world, perfectly suited to Titanoboa, would not last. Something was already changing, something invisible. 3 million years of dominance, then gone. Not how Titanoboa lived, but why it vanished. 3 million years of unchallenged dominance. Then, silence. No gradual decline, no warning. Titanoboa simply vanished from the fossil record. The most powerful predator the post-dinosaur world had ever seen. Gone. What could end something so perfectly built? The answer begins with temperature. Cold-blooded animals depend on heat. Remove the heat, remove the advantage. Around 55 million years ago, global temperatures began a slow decline. The greenhouse was cooling. For Titanoboa, this was not a minor shift. Every degree lost directly attacked its biology. Cold-blooded metabolism slows with temperature. Digestion fails, reproduction drops. The giant becomes a liability. Size, its greatest weapon, became its greatest weakness. A larger body demands more heat to function. The ecosystem Titanoboa had shaped for millions of years began to shift without it. Prey moved freely again. The silence Titanoboa had created, that force bending everything around it, began to dissolve. That is the true measure of Titanoboa's dominance. Its absence changed the world as much as its presence had. Cooling temperatures alone may not tell the whole story. Some scientists point to something else: competition. New predators arriving from connected landmasses, ecosystems that had been isolated, suddenly open. Titanoboa's niche, built over millions of years, was no longer exclusively its own. Pressure came from multiple directions. The fossil record goes quiet. No gradual shrinking, no clear successor. Titanoboa simply stops appearing. 58 million years ago, the heat built the perfect predator. The cold simply unmade it. Something of Titanoboa survived, not in stone, but in the living giants that still exist today. Still here, not as fossils, not as memory. Living giants coiling through the same tropical heat. The reticulated python, the longest snake alive today, a direct echo of a world Titanoboa once ruled. What can these living giants still teach us about Titanoboa? Scientists study living constrictors to reconstruct Titanoboa's muscles, metabolism, and hunting behavior. The green anaconda, heaviest snake on Earth today, reaches barely a quarter of Titanoboa's estimated mass. Both species share the same blueprint: ambush, constriction, patience. A strategy perfected 60 million years ago. Modern snake physiology is a window backward. Their heat-dependent metabolism mirrors what climate did to Titanoboa. Remove warmth, and even today's giants slow, struggle, and become vulnerable. The same equation unmade Titanoboa. That is the answer fossils alone could never give. Living snakes confirm what stone only suggested. Herpetologists measuring anaconda constriction force have extrapolated figures for Titanoboa. The numbers are almost beyond comprehension. Scale that force to 13 meters and over a ton. Nothing in Titanoboa's world could have resisted it. Modern giants face a threat Titanoboa never encountered. A world remade by something other than climate. Habitat loss, poaching, persecution. The living descendants of the world's greatest predator are disappearing from their ecosystems. Titanoboa needed perfect heat and endless forest. Its descendants need the same, and that world is shrinking. The deepest lesson these living giants carry: the conditions that built something extraordinary can vanish without warning. The ripples fade, the river stills. Somewhere beneath the surface, the legacy of Titanoboa continues. For now, 60 million years ago, the world belonged to a serpent, born from catastrophe, shaped by heat, perfected by time. It ruled through patience, power, and mastery of its environment, not speed or ferocity. Then, the climate cooled. The greatest predator the Paleocene had ever produced vanished. For 60 million years, Titanoboa lay forgotten, buried beneath Columbian coal, until a single vertebra changed everything. That fossil rewrote our understanding of post-dinosaur life and how extreme heat enables extreme scale. Titanoboa is not just a prehistoric curiosity. It is a warning written in stone about climate, scale, and collapse. Living giants like the green anaconda carry echoes of Titanoboa's blueprint. In a world warming once more, a warming planet could, in theory, unlock gigantism again. Evolution has no ceiling, only conditions. Titanoboa leaves one question: if the heat returns, what comes next? If this moved you, subscribe. More lost worlds are waiting.